create 3 global alias tags. So where do we always go to create global tags? Controller tags. So let's open up controller tags folder. Let's go into edit tags. And while we're here, I want to refresh your memory on this stuff. You don't have to do this, but just look up here. So we have these controller tags that are already in there, right? All of the I/O are always what kind of tags?
Puts and outputs.
All your I/O? Local. All of your inputs and outputs are always going to be controller tags. They're always going to be global tags. Because we want any program to be able to access those tags, right? So they're always going to be global tags. The first part of the I/O tag structure tells us the location of where that module is. This says local. That means it's in the local rack. If it weren't in the local rack, it would say remote, right? The local rack is the rack where the PLC is installed. The remote rack is some other rack, it's just for I/O. I think we talked about that last time. Oh, we did last semester.
I can't remember last semester.
I think I'm gonna have to start with a bullet point list of different things. I'll talk about things in one class and forget about the other class.
Well, that 1 month break is what kills you.
Right. That's right. So it says local :1, local :2, local 3, and so on. What's the next part of that tell us? What's the 1? It's the slot number, right? Yeah. Local 1, local 2, local 3. So we know it's a module that's located in the same rack as the PLC in slot number 1. And if you look on your trainers, yeah, it's embedded I/O, but they're calling that slot 1, that first slot, where the 2 edge connectors are, or 1 edge connectors, whatever that is. 2 I/O connectors. And we know by the exercise we went through the other day, that first slot, what's it contain? Inputs, outputs, or both? Both. Yeah, inputs and outputs. So that's why we have local 1I data, local 1I data, and then we also have local 1O data. And here's the key. The local 1I fault, that's data also. That's the data that we're going to get back from the module itself, right? If you notice, there's 32 bits in this. It's a double integer data type. But when we click on local 1O, there's not a fault data file in there, right? Does anybody know why? Maybe they didn't want it to be there?
It'll never get to the output and fall.
Here's the thing, since they're both in the same slot, we have, if we look at local 1I data, we have 16 bits, right? 16 inputs. The local 1O data, we have 16 outputs. Local 1I fault, we have how many bits? 32 bits. You think that's just a coincidence? That's right. So that's the fault data for both your input, all your inputs, and your outputs. That makes sense? They're using one double integer, 32 bits, for the 16 inputs and the 16 outputs. Clear as mud now?
Clear as mud.
What do we left?
Could they have done it on the output side just as easily?
Probably, yeah. It's a lot well engineered.
That's the make promise.
So we have the location, we're in the local rack, we have the slot number, the I, that's the data type of the module. The fault, data, and readback, those are also, that's data also, but it's the type of data that is processed by the module. It's a little bit, those two are a little bit fuzzy. You have input data, output data, but you also have this fault, data, and readback.
Was that feedback the one you said you never had to use?
Yeah, yeah. Yep, that's exactly right. Anyway, so I needed to explain that to you, and that's in the quote, I think in that PowerPoint too. So something you need to be familiar with for the test also. Anyway, so we're gonna create these global tags. We have to be in controller tags to do that. It says we're gonna create 3 global alias tags. One of them is stop, go ahead and do it, stop PB. Just to get you more and more practice. Believe me, I wasn't born knowing this stuff. I spent a lot of time fumbling around. Like I said, and I probably, about 90% of what I know, I taught myself this stuff. So, just doing it, just doing it, just doing it. And we're gonna alias this thing that says to note, use the correct I/O for the corresponding push buttons and lights that are on the trainers. Use the first set of red and green push buttons. Local 1I data, bit 0, stop. Go ahead and make your start. PB tag, local 1I data 1, and you can use that shortcut, right? You can do a copy, paste it, and then just change the bit number. Control C, Control V.
It's an engineer's favorite function.
Huh?
It's an engineer's favorite function.
Control C, Control V.
Control paste, copy paste.
Paste, copy. Make things quick. And the power on. Local 1O data. Bit 0. So we've got that covered. Number 3, it says using the bold data type, create 2 base tags for the tag names, master control relay. Bold data type. And control relay 1. The bold data type. And here's what makes those base tags. If we don't alias them to anything, if they're not aliased to anything, it's a base tag. It's just automatically a base tag. Just so you know. Then it says create a timer tag using the tag name timer. Timer, and then it says to create 5 of those using the array dimension. Then it says create 3 local tags. So over in main task, under main program, parameters and local tags. Those 3 local tags were what? Stop PB2, start PB2, stop PB2. And it's going to be aliased to the next set. Local 1I data 3. Do the start, PB, 2. Data 4. And then it says a power on, a tag called power on 2. Local 1O, data 1. Then it says use the bold data type, create 2 local base tags using the tag names extend cylinder and retract cylinder. So we've created 5 local tags. 3 of them are alias tags and 2 of them are base tags. And if you notice, you see the alias here, it says local 1I data 3 and C in parentheses. That's telling you that it's a controller tag.
It feels like it flows so much better this last time.
It is, once we get rolling in this thing and everybody gets comfortable with navigating and doing this stuff, yeah, it goes really good. And then it tells us to add in an AC input module. And maybe we didn't cover this the last time, no. I apologize for that. Like I say, I've got to start keeping a bullet list of things that I talk about, I'm thinking, starting in the Monday class, I guess.
Just check it out when you actually.
It doesn't, I used to keep a spreadsheet because I was teaching like 5 classes. I couldn't remember what I talked about. But yeah, I used to keep a spreadsheet and a checklist.
You can always upload us your lesson program to us on Blackboard.
Yeah, it's an idea.
We
give you an idea. Yeah, and I've told it this before, this class here has just kind of evolved
Yeah.
in the last couple of years. So I'm constantly changing it, making it better, yeah. When I first started this thing, it wasn't, yeah. Anyway, so it says add an AC input module. So we right click on 1769 bus, and like I say, I apologize, I know most of you had to fumble around to try to figure this out. New module. And we deselect everything here in the module type category, and we just want the digital. And we pick the first one in the list, create. And here's the thing, when you add a module like this, you want a good descriptive name on it, right? So just call it AC inputs. Capital A, capital C. That way you know what exactly that module is for. And then it's said to change the electronic keying. Did we talk about electronic keying last time?
No.
We don't,
No.
I don't believe so.
No? I read everything.
That's why we were so long.
I apologize. That's bad. So, all the modules, they have these revisions, right? And this is key information that you'll need to know and want to write down for Thursday, next Thursday. They have a major revision on the left and a minor revision. And that refers to the firmware of the module. So So it's like the ROM or the EEPROM that's inside the module. That's the firmware. This module, this particular module, the major firmware just happens to be a value of 1, the minor has to be a 001. Major, minor firmware revisions. The major firmware revision, it tells the PLC the functionality of the module. Input module, AC module, DC module, the major functionality of the module. The minor firmware revision tells it the features of the module. The documentation says anomalies or corrections.
It tells what?
The documentation, it tells the PLC the features of the module, yeah. Whether it has error reporting, fault reporting, that type of stuff.
What was the major description?
Functionality. Major is functionality, minor is features.
Crash is just my display like from the source.
Good? I know it's a headbanger. So, and here's the key. We have this electronic